Okay, what we're going to do right now is we're going to take what we did with systems of inequalities and apply it to a situation or word problem. So a couple steps we're going to follow. We're going to solve a word problem. Step one, we're going to write our let statements. Step two, we're going to write the system of inequalities. So we kind of started this work last week reviewing how to write inequalities from a situation. Step three, we're going to graph each inequality and find that solution region. And then step four, we're going to pick a solution. So, example one, Sarah is selling bracelets and earrings to make money for summer vacation. The bracelets cost $2 and earrings cost $3. She needs to make at least $100 and she has enough material to sell up to 20 bracelets. How many of each could she sell? So, what I've gone ahead and done is I've labeled my Y and X. So, I said let Y be the number of bracelets, let X be the earrings. All right, so let's look at our system. A couple things. We know bracelets cost $2, earrings are $3, and she wants to make at least $100. Okay, so bracelets is Y. So we know that $2 for bracelets plus $3 for earrings has to be at least $100, which means she needs to make more than or equal to $100. The next sentence says she has enough material to sell up to 20 bracelets. I mean, she can make up to 20 bracelets. So her number of bracelets, which is Y, has to be less than or equal to 20. She can't sell more than 20 bracelets. All right, so we have our let statements, our system. Now we're going to graph. First one, not in slope-intercept form, so we're going to change it to slope-intercept form. So we're going to subtract 3x and then divide by 2. That's going to transform to y is greater than or equal to negative 3 halves x plus 50. So we're going to go ahead and graph that. So I start at a y-intercept of 50, down 3, right 2. Now, because my axes are counting by the same interval, I can just count down 3, right 2. So down 3, right 2. If they weren't the same interval, I'd have to be a little bit more careful. Down 3, right 2. Down 3, right 2. And that is going to be a solid line. So we're going to go ahead and make that solid. All right, and our next one, y is less than or equal to 20. Our bracelets are less than or equal to 20. So I'm going to go to y, bracelets, 20. It's a horizontal line. Every y is 20, and it's going to be solid again. Okay, so I have my two lines. I forgot to do the shading, so I'm going to back up here, and I'm going to do my shading for my diagonal line. So I'm going to take 0, 0, 0 greater than or equal to 50. Is 0 greater than or equal to 50? No. So I'm not going to shade the part that includes 0, 0. I'm going to shade the other side. So I'm talking about all of this. All right. Next question, or next shading, 0 less than or equal to 20. Is 0 less than or equal to 20? It is. So that means I'm going to shade below the line. And where's my double shaded region? It's going to be right here. So that tells us that any combination of bracelets and earrings that is in this shaded region would work. So let's pick one. Let's make this easy. Let's go 40 and 5. So I'm going to say she can make 40 earrings and 5 bracelets. She can make 40 earrings and 5 bracelets. If we do the math there, does she have less than 20 bracelets that she's selling? Yes. 40 earrings. So 40 times 3 is 120, plus 5 times 2 is 10. That's $130. Is that enough money that she wants to make? Yes. So this would be a solution. It's not the only solution. There's a bunch of combinations, but that is one of them. All right, let's take a look at one more application of our systems. We're hosting a party. So we got Jason. Let's see here. Jason is hosting a party. Jason's buying wings and hot dogs for the party. One package of wings costs $7. Hot dogs cost $4 per pound. He must spend less than $40. Okay, so he's got a budget here. He plans on buying at least 5 pounds of hot dogs. Okay, so again, I defined my let statement. I said let Y be the number of hot dog pounds, let X be the number of package of wings. So let's start with money. Wings are $7. So wings was X, so 7X plus the cost for hot dogs, 4 times the number of pounds. Y has to be less than 40. So we have to be less than $40 to be within budget. Our other inequality says we want to buy at least 5 pounds of hot dogs. So we want our hot dogs, which is Y, to be more than or equal to 5. Okay. Again, not in slope-intercept form. If we were to change to slope-intercept form, we would get Y is less than negative 7/4 X plus 10. So that's the inequality we're going to want to graph. All right. Let's take a look. Y is 10. Down 7, right 4. I'm going to check my intervals, counting by ones, so we're good. So down 7, right 4. 1, 2, 3, 4. That is going to be a dashed line. Well, actually, let's think about that. Want to spend less than 40? Can we spend 40? No. So yes, it has to be less than or has to be dashed. All right. So I have a dashed line. Not very good at my dashed line today. All right. So there's my dashed line. I'm going to shade it right away. 0. 0 less than 10. Yes. Which means I'm shading this part with 0, 0. All right, we're almost done. Y is greater than or equal to 5. So I'm going to 5 on the Y. It's going to be a horizontal line. Solid because it can be equal to. And 0. Is 0 greater than 5? No. So I don't shade it below with the 0. I shade above. So all of this. And I look for that double shaded region, which is right here. That means any combination that fits in that shaded region, as long as it's not on that dashed line, will work. So I'm going to make it easy. I'm going to grab this point right here. It's kind of hard to see. I'm going to draw an arrow. So I'm going to call that'd be 1 package of wings. And 6 pounds of hot dogs. 6 pounds of hot dogs. Does that satisfy our original? All right. Well, 1 package of wings is $7. 6 packages of hot dogs at $4 a piece. That's 24. 24 plus 7 is $31. So I'm within budget. And I need more than 5 pounds of hot dogs, and I bought 6. So that is the solution, or a solution to this problem. And that is systems of linear inequalities application to a word problem or situation.